So, this is the NumiQueen from Nixie Kits EU. It's a pretty big box. I've already had it open just to check what's inside, but I'm going to show you step by step how it comes out of the box. And I have to say, it's everything about it says quality. You get what you pay for. It's not a very cheap piece of kit, but it's certainly worth every penny. So when you first get the box, it's delivered by tracked post. So it's delivered with a tracking number by priority post. When you look inside, the first thing that surprises you is that there's a power adapter included. There's a plug and a high quality power lead. It's even been localized because the address on the box was Switzerland. It's got a Swiss plug on it. It's just attention to detail. And then there's the kit itself. And there's even a case in there. So, and ceramic tube holders and a nice printed colour manual. So first impressions are very, very, very good indeed. At the same time, this is actually what I've been waiting for. I had to order some IV-13 tubes, and again, these are absolutely beautiful. You probably can't see very much of them there. They'll make more sense when we actually get them lit up, but there are tiny, tiny filaments inside. And one of the features of the NumiQueen clock is that they're actually driven by constant current drivers. So constant voltage drivers tend to overdrive some of the filaments and underdrive some of the other filaments, but the NumiQueen gets around that by having a constant current driver for them. So they'll all be driven in the same way, regardless of any physical differences in the filaments themselves. One of the things that causes Numitrons to get old and eventually die is the Inrush current. Just like an incandescent bulb, when you turn them on, initially they draw much more current than they should, and this ages the filament. And the feature, I think that the key feature of the NumiQueen clock is that the drivers, the constant current drivers, don't allow the overdriving of the filaments, so you can expect to get the full life out of the tubes, and the full life is something like 50,000 hours. So I'm looking for a long and happy relationship with this clock. This is a clock kit which is aimed at the slightly more experienced hobbyist. The instructions in the assembly manual are quite short. They contain all of the essential information, but they don't give you much guidance about how to go around putting it together. Jürgen says in the assembly manual that you should just start at the smallest components and go to the biggest, but any of you who watch this channel will know that I don't like to do things like that because I like to test as I go along. So if I've got a nasty surprise coming, I like to encounter it as quickly as possible and know that it happened in the last step, and then I have very much less to debug than if I do everything in one go. So the key for me is to go through the schematic and basically understand the various sections of the schematic, and then put together the kit in the order, or in a logical order, of the various components of the kit. And I usually like to start with the power supply components, and then move on to the controller and any supporting hardware around the controller, like switches or speakers, and then go on to the tube drivers, the LED, depending on if they have to be mounted under the tubes or not, and then finally the tubes themselves and anything that's peripheral to the clock, such as RS-232s or interfaces to GPS or DCC time sources. So I'm going to go around this in that order. And then the first section is going to be that we put together the power supply module, which is a fairly normal linear regulator power supply based around a low dropout LM1117. And this then will compose the components BU2, C9, C10, IC8, LED9, C11, C12 and C13. So this is the first part of the construction. We've got the main input power socket, a barrel jack, which then goes into a smoothing capacitor, a 330 microfarad smoothing capacitor, then goes into the LM1117, which is surrounded by some decoupling capacitors and an output smoothing capacitor. And a fairly unusual thing is that the LED, the amber LED, actually forms an active part of the circuitry by taking the ground of this 3.3 voltage regulator slightly off ground, so about 2 volts off ground, and it's got a smoothing capacitor around it, and that has then the effect of pumping up the output voltage from 3.3 to about 5.3 volts. So these aren't soldered on yet, but I'll solder them on now, and then we'll have another look and we'll power it up and see how we get on. So that's the first step of the build. Well, with the first part of the build done, there's the nice amber light running, and it's linked up to my brand new high quality power supply. There it is, and we're all good. Step is we're going to put the controller on with the surrounding components. So this is the controller. It's still in the anti-static bag, but I'll put the socket in, the crystal, the ballast capacitors for the crystal, so that's C7, C6 and C8. This is Q1. There's D1, which is a 5819. There's C4, which is a 1 microfarad. There's C16, which is a 1 microfarad. A speaker and switches S1, set, S2, adjust, S3 alarm and S4 DST. So we're going to put those on the board, and then we will test again, and hopefully it will do some beeping for us. So here we are with the controller mounted and the switches, and hopefully now something will beep when we press a button. No, no, yes, yes. Okay, so we are alive. I also added LED 1 and LED 2 along with R22 and R18. You can just see R18 there. So now that we can drive the LEDs for the DST, daylight saving time, and data. So I've installed the LEDs and also the dip switch from the other side. I've followed the instructions that all of the dips have to be in the off position. Now I'm a bit confused what to do with the 3mm LEDs. I've noticed though that they pass through the holes in the board, so they can go in there. I can fit them after I've fitted all the rest of the components, so that means I'm going to put the sockets on and the tubes and the drivers in. I'm going to put all 6 of these drivers in, do the driver circuit. Then once I can see that the tubes are lighting up, then I'll put the LEDs in practically as the last step. I'm not even sure that I'll take these. I don't know what colour they are, and maybe I don't like them. But so that's the next step. Driver chips, tubes and the other components around the drivers there. I've fitted all of the rest of the components for the LED, the backlight LEDs, but They don't seem to be working yet, so maybe I need to fit them as the last thing. The drivers doesn't seem to be very hard at all, so it's the 16 pin sockets. I'll put all 6 of those in, and then there are 6 590 ohm resistors to go in, and that seems to be about it. And then of course the sockets, they're quite tough to get in, but with a bit of persuasion they go in okay. So here we are for the moment of truth. Let's plug the power in, and this is the first time I've done it, so here's hoping. According to the instructions it should start counting up from 0 to 9. I've only put 1 tube in just in case. If this works okay, I'll put the rest in. Yay! 1, 2, 3, 4, 5. Cool. Nice. No smoke? Not too much heat? I think we're good. So I'll put the rest of the tubes in, then we'll see. So there we go. All of the tubes in. They all look to be working perfectly. So that's really good. This one over here looks a little bit less bright, but that's just the phone. That's just the camera. Like when we go around here, it's just as bright as the others. So cool. And here we have it. The finished product. Counting away merrily. Now all that remains to do is to put it in the case and have a good old play with it.